Section 9.1, Parabolas and Circles. So the first thing we're going to do is find the distance between the points 6, -4, let's plot that point, 6, -4, and 2, -7. 2, -7. We want to find the distance between these 2 points. How will we do that? It's at a slant, so can't really just measure it. But what if we sneakily created a right triangle? Would that help us? How would a right triangle help us? We know that the distance from here to here is 3. You can see it. You can count the squares and measure it. The distance from here to here is 4. Those are the legs of the right triangle. So if we want to know this distance, the hypotenuse, all we have to do is use the Pythagorean theorem. We know that the hypotenuse squared equals the sum of the legs squared. So the hypotenuse squared equals 16 plus 9. So the hypotenuse squared equals 25. So the hypotenuse must be 5. That's our distance. Well, can we think of some formula maybe? How did we get 3? If we look at these 2 points, how could we come up with 3? Notice that 3 is the vertical distance, and the variable that measures the vertical distance is the y variable. What do you notice about those y values? -4 to -7, they're 3 units apart. The horizontal distance is 4, and the variable that measures the horizontal distance are 6 and 2, the x variables, and they are 4 units apart. So what we're going to do to calculate distance is we'll come up with a formula that will give us these legs on the triangle. So the distance squared equals the horizontal leg, the blue leg, that's the difference in the x values. And then you want to square it because the Pythagorean theorem says to square all the sides of the triangle. And then we need the red leg, the vertical leg. That's the difference between the y values. And we want to square it too. So our distance will be the square root of these values. And that's our equation for the distance between 2 points in the plane. Let's use that equation to calculate these distances. The distance between 9, 9 and -9, -9. So we want to take the square root of the difference between the x values squared plus the difference between the y values squared. Notice that each of these has minus a negative, which we can change to plus a positive. So that's 9 plus 9, that's 18 squared plus 18 squared. What is 18 squared? 324. So it's the square root of 648 That's the square root of 324 times 2. And the square root of 324 we know is 18. If we're doing this as an application problem, we might need a decimal approximation of it. So 18 times the square root of 2. 25.456, approximately 25.456. That's our distance between those 2 points. Let's calculate the distance between these 2 points. We want the square root of the difference between the x values squared plus the difference between the y values squared. The square root of 5 squared plus 16 squared. 25 plus 16 squared, 256. +25 plus 256, 281. And if we need a decimal approximation of that, take the square root, it's 16.763. Let's just always put 3 decimal places for our accuracy. Let's find the distance between these points. They have decimals, but that doesn't matter. 6.1 minus 5.6 squared plus 2 minus a negative 4.4 squared minus a negative is the same thing as plus a positive. So we have 0.5 squared plus 6.4 squared .25 plus 6.4 squared, 40.96 plus 0.25, 41.21. And when we take the square root, we get approximately 6.420. We had to round up. 6.420. Let's try to find the midpoint of a segment with the given endpoints -1, 9, and 5, -3. -1, 9, and 5, -3. So let's look at this graph and see if we can figure out where the midpoint is. Now the midpoint is the distance that's halfway in between. And if we look at this and kind of eyeball it or get our ruler out, I think we'll see that the midpoint looks to be right about here. So our 2 points are the point -1, 9, and 5, -3. And we're saying that we think that our midpoint is somewhere around 2, 3. So if we compare these x values, do we notice something about that? If we compare the y values, do we notice something about that? How far apart? How far is it from 5 to -1? That's a difference of 6 units. From -1 to 5, a difference of 6 units. Let's draw that on here. So we go over 6 units, and our midpoint looks to be right in the middle of that. How far is it from 9 to negative 3? Looks to be about 12 units. And our midpoint is right in the middle of that. So how can we calculate our midpoint? Well, it looks like we can take our x values and divide by 2. We can take our y values, add them together, and divide by 2. That's our midpoint. So the midpoint formula, if the endpoints of the segment are x1, y1, and x2, y2, then the coordinates of the midpoint are, you just want to take those x values, add them together, and divide by 2. Take the y values, add them together, and divide by 2. And that gives us our midpoint. So we just average the x coordinates and we average the y coordinates, and that gives us our midpoint. Some examples. We're going to add the x values, divide by 2. Add the y values, divide by 2. 7 halves, 6 halves, 3 1/2, 3. That's our midpoint. 6, negative 1. Let's add our x values, divide by 2. Add our y values, divide by 2. 1/2, 11 halves. We could write that as 1/2, 5 1/2. And that's our midpoint. Doesn't matter if they're fractions. We'll just add the x values together and divide by 2. We'll add the y values together and divide by 2. Negative 4/5 plus 1/8, negative 27/40. Let's try that again. Negative 27/40 divided by 2. I like to think of that as divided by 2 over 1. Negative 2/3 plus 3/4. That's 1/12 divided by 2, or divided by 2 over 1. And remember, we divide by fractions by multiplying by the reciprocal. So it's negative 27/40 times 1/2. That's negative 27/80. 1/12 times 1/2, 1/24. That's our answer. That's the midpoint. So what is defined as the set of all points in a plane that are a fixed distance from a point in that plane? It's a circle. We want to draw a circle centered at the origin with a radius of 5. So we want to go 5 units away from the origin. We can go right and get to a point. We can go down. We can go left. We can go up. We can go at a slant to get 5 units away from the origin. And that gives us a circle, sort of. It should be a circle. So what's the equation of that circle? Well, let's think about that. If the distance always stays 5, we know our distance formula is the square root of the difference between the x values squared plus the distance between the y values squared. So our distance is 5. We know that. And what are our x values? Well, let's call any point on the outside of the circle, let's just call it xy. So that's going to be x minus, what's x2, y2? The distance between the 2 points, that'll be the center, the origin, and we know that's the point 0, 0. So x minus 0 squared plus y minus 0 squared. I don't like that square root. Let's square both sides, and we get 25 equals x squared plus y squared. That's the equation for a circle with radius 5. And in general, if you want the equation of a circle centered at the origin with radius r, you're going to take the radius squared equals x squared plus y squared. That's our circle. Centered at the origin, radius r. Let's draw a circle centered at the point 1, 2 with radius 8. So we need to go 8 units to the right, 8 units down, 8 units left, 8 units up, and then use those points to help us eyeball our circle. Oh, that's a terrible circle, but you get the idea. We want to stay a distance of 8 units away from the point 1, 2 at all times. So let's use our distance formula again. We know the distance, we're talking about the distance between the center, 1, 2, and any point on the outside, which we'll call xy. We know the distance will be 8. So 8 will be the square root of the difference in the x values, x minus 1 squared. The difference in the y values, y minus 2 squared. Let's get rid of that radical. Square both sides, 64 equals x minus 1 squared plus y minus 2 squared. That's our equation for that circle. The equation of a circle centered at a point HK with radius r is, we'll just start with r squared, and we'll take our x minus the h value squared plus the y minus the k value squared. And that's our equation for our circle. Let's find an equation of the circle having the given center and radius. This one's centered at 0, 0, so h and k are both 0, or we had another formula where we just had x squared plus y squared equals the radius squared, 5 squared, 25. That's the equation for this circle, centered at the origin with radius 5. Center 4, 1, radius square root of 3. So we take x minus 4 squared plus y minus 1 squared, and that equals our radius squared. What is the square root of 3? And then we have to square that. That's just the number 3. So 3 equals x minus 4 squared plus y minus 1 squared. Let's find the center and the radius of each circle, and then graph the circle. So we'll look at the equation. The center, notice it equals the radius squared, it's on the right this time. The center, remember it's x minus the center value. So x minus 2, so that will be centered at the point 2. It should be y minus. If you had to force yourself to write this as minus, it would be y minus a negative 3. So it's actually a negative 3. It's centered at the point 2, negative 3. You can think of it as these values are the opposite of what the actual center is. And our radius, that's the radius squared, 25. So our radius is just 5. So 2, negative 3. Radius of 5. I like to put those points where we go left, we go right 5, we go down 5, we go up 5. Those points help me draw the perfect circles that you see every time. Well, think how bad they would be if I didn't draw those points. What about this one? Where's the center of this circle? Negative 4, remember it's the opposite. There's nothing subtracted from y, so it must be 0. Negative 4, 0, and what's the radius? That's the radius squared. The radius is 3. Negative 4, 0, and let's draw those 4 points. Radius of 3, so we're going to go over here, we're going to go down 3, we're going to go left 3, and up 3. And that will give us our circle. I hope that you can draw a better circle than I can. And that's all from section 9.1, the last and final section in Math 99. Congratulations, you have finished the course material.